Alright, so we continue from where we left off. We're going to look at the part D, which says using a vector method, determine the position vector of M, the midpoint of the line PQ. When it says using a vector method, it means you're going to be writing OP equal this and that and the other plus and so on and so forth, instead of using the drawing. But we're going to use the drawing to help us, alright? Or the graph. Let's look back at the graph. The midpoint of PQ. Midpoint of PQ would be somewhere here. So if we should look at the midpoint of PQ and we draw a line to there, we just say somewhere about here. Alright. So M, let's put an M there. Let's put our M right here, but we're going to move it here. We're just fixing up the M and then sliding it in place. So we want this to be medium size. Alright, so the M will be there. So it's P going up to Q and then the M in the middle. What we're going to do is erase some of these things we have to make space and slide this up. Alright, so just as a reminder, PQ goes this way. Alright, just wanted to remember PQ goes this way, and then our O is somewhere down here. Slide to here and slide to here. Good. So we have our P somewhere here and our Q somewhere up here. M would be here. Alright. So if we have a line OM, it would look somewhat like this. Line from O to M. Alright, so here it says using a vector method, determine the position vector M. The position vector M would be the vector from the origin O to M. So we have O here to M. So we want this vector OM, the vector OM. What is it? If we put an arrow here, we see we're going from O to M. What we can do here is to say, if we have OM as the resultant, by the way, we put two arrows on the resultant, alright, and one arrow on each of the vectors we're adding. We could form a triangle with OMP, and then we see that if we're going from O to M, if we go around the triangle, we'll go from M to P. But we're not supposed to be following the other two sides of the triangle. Or, in other words, guess what? Let's take this triangle and put it separately. Put it out here separately. So here now, we have P, M, and O. So this is what we have here. We're just taking the triangle out of this diagram and put it into one side to reduce confusion and so on and so forth. Alright, so here now, OM, if we follow around the triangle, MP and OP would be the other two sides of the triangle. The arrows on this side should oppose the arrow on the resultant. This arrow must follow the arrow on the other side, but it must oppose the arrow on the resultant. So remember what that means is that if we walk around the triangle like this, we would follow the arrow on the resultant, but will be opposed by the arrow on the other two sides of the triangle. So here now, OM, from O to M, is equal to PM. Oh, let's do it this way. Is equal to OM is equal to OP plus PM. Alright? Now, from P to M is halfway going from P to Q. Now, what was PQ again? PQ is 5, 10. And you can see that if you go from P to M, you're going halfway. Then halfway the distance you would have gone if you had moved from P all the way up to Q. So it's PM is half of PQ. So what we have is OP plus half PQ. Alright? You see that? Now, OP was what? What was OP? OP was 7,5. So we have 7,5 plus half PQ. And PQ was what again? PQ was 510. Half of 510. You can see that. Alright? Now, what we have here, therefore, is 7, 5 plus 2.55. 5, half of 5. Remember, the half multiplies each number inside the brackets, so half of 5 is 2.5, half of 10 is 5. So what you end up here with is 7 plus 2.5 would be 9.5, 5 plus 5 is 10. So it's 9.510. You see that? So OM is equal to 9.510. It's not what we have there. So let's write it down here. OM is equal to 9.510. Now, suppose we had done it using MQ, this side of the triangle. What would happen? Would we get the same answer? Well, we're supposed to, but let's try and see what would happen in that case. Here, if we consider MQ and then O and P, we're taking this side of the triangle, and let's highlight this part here. what we have here is M and Q, and we have O here. Alright? So we're just taking out this side, that triangle there. That's what we're looking at. Now the thing is, what we want is OM. This will be the resultant. So OM would be OQ plus QM. So OM will be equal to QO. We're going, I said OQ, hold on. Oh yeah, it is OQ, right. OM would be OQ plus QM. Remember, you're not, as you walk around the triangle, right, going around the triangle, if I follow the resultant, when I go like this, I should be opposed by the arrow and the other two. So while I follow the resultant, I'm opposed by the arrows and the other two. So the arrows and the resultant must be opposed by the arrows and the other two. Vectors. So here now, we have OM is OQ plus QM. What was OQ again? Let's look at OQ. OQ was 1215. So it's 1215 plus QM. But from Q to M is halfway from Q to P. So this is half QP. Because the thing is, if you go from Q to P, you go all the way there. But going from Q to M, you stop halfway. So QM is half QP. But then QP now, we want QP. It would be the inverse of PQ. PQ was 510. So here, what we have is 1215 plus half of negative PQ. Half of negative PQ. Because QP is the negative of PQ, the inverse of PQ, alright? Now, PQ was 510. So PQ was 510, so what we have is 1215 plus half of, no, PQ is 510, so QP, negative PQ, which is QP, is negative 5, negative 10. So here now, we have 1215 plus half of negative 5 is negative 2.5, half of negative 10 is negative 5. So what do we have? Negative 12 minus 2.5. 12 minus 2 would be 10 and minus 0.5. 10 minus 0.5 is 9. And then we have 15 minus 5, which is 10. So we have 9, 10 there. Was it the same thing as before? Oh, 9.5. 10 minus 0.5 is 9.5. So it would be 9.510. Right, so we see we get the same thing. So we had used, oh no, we had used this triangle before. This was the triangle we used, and we got 9.510. And then in the second case, we used this triangle and got back the same 9.510. So it wouldn't matter which one you use, you get the same answer. Alright? Alright, so that is it for this question.